Mean value theorem states that if a function f is continuous on the closed interval ab and differentiable in the open interval ab, then there exists a point c in the interval ab such that e prime of c is equal to the function's average rate of change over ab. So from this one, the curve a to b function of x at the interval ab, there exists a point c, this one, as long as this curve f of x is continuous. Number one, continuous. Number two, differentiable in the open interval ab, and that e prime of c, this one, e prime of c equals to fb minus f over a all over b minus a. So we'll take up an example on this one. Find the number c that satisfy the mean value theorem for the function f of x equals to x squared minus 3x plus 1 interval. This one is 0 to 4, so interval is 1, 0, so make this one as a, this one is b, 0 to 4. So this one is 0 to 4. This one is b. So a to b. This one is secant line. This one is tangent line. This one is point C. So make this one as point C. Or somewhere else, this one is C. So the steps here, if this one, the number c would satisfy this function, AB is that evaluate the functions at endpoints interval. So evaluate the functions at B and of course at A. So this one, so f of 4 equals to 4 square minus 3, 4 plus 1 equals to 5, and f of 0 equals to 0 square minus 3 times 0 plus 1 equals to 1. We'll find the derivative f prime of c. So the derivative of this one is 2x minus 3. So that one is f prime of c equals to 2c minus 3. So form the equation f prime of c. This one f prime of c, 2c minus 3 equals to fb. So you have that one is 5 minus fa 1 all over b minus a. So b minus a is 4 minus 0 yung c. So 2c equals to 3. 3, then you have that one, 2c is minus 3, no? 2c minus 3 equals to 5 minus 4, this one is 4 all over 4, so 2c equals to 1 plus 3, so equals to 4, therefore c equals to 2. So this one, c equals to 2, is the number c satisfy the mean value theorem. For number 2, find the number c that satisfy the mean value theorem for the function f of x equals to x squared minus 2x plus 3 on interval 2 to 6. So this one is A, this one is B, this one is C, this one is f of x. So steps as follow. Number 1 is evaluate the function at a points of interval 2 to 6. So this one, f of 6 equals to 6 squared minus 2 times 6 plus 3 equals to 27. F of 2 equals to 2 square minus 2 times 2 plus 3 equals to 3. So find the derivative. So the f prime of c equals to 2c minus 2. So form the equation. The equation is this one. 2c minus 2 equals to f of 6 minus f of 2 all over b minus a equals to 27 minus 3 all over 6 minus 2. So your c, so you have this one, 2c equals to 24 all over 2 over 4 plus 2, or c equals to 4. So this one is the value c that satisfy the mean value during interval of between 2 and 6. The number c that satisfy the mean value theorem for the function minus x squared plus 4x plus 2 on the interval 1 and 3. So this one is a function of x, the curve. Then this one is a, this one is b, this one is c. So we have to prove that number c, this one, satisfy the mean value theorem. So evaluate the function in points interval. So that one is f sub 3 equals to minus 3 square plus 4 times 3 plus 2. So 1 equals to 5. Then f sub 1 equals to minus 1 square plus 4 times 1 plus 2 equals to 5. So find derivative f of c. E prime of c equals to 4 minus 2c. Form an equation following e prime of c equals to fb minus fe all over b minus a. So 4 minus 2c equals to 5 minus 5 over 3 minus 1. Then you have that 1c equals to 2. So the number 2 is the numbers that satisfy the mean value theorem for the f of x equals to minus x squared plus 4x plus 2. This c there equal to 2 is in between interval of 1 and 3. So we'll pick up this one, number 4. Find the numbers. Find the number c that satisfy the mean value theorem for the function minus x squared minus 3x plus 5 interval of 2 and 8. So this was a 4. This one is your f of x. Then this one would be your 2, there your a. This one is your b. Somewhere interval of a and b is the c. So this one c. A c is a point that will satisfy the mean value theorem. So evaluate the function. So f of 8 equals to x squared minus 3 times 8 plus 5 equals to 45. F of 2 equals to 2 squared minus 3 times 2 plus 5 equals to 3. So find the derivative f prime of c equals to 2c minus 3. So form the equation. 2c minus 3 equals to f of 8 minus f of 2 over b minus a. For that one, your b is equals to 8 minus 2. So if you simplify this one and solve for c equals to 5. So this value 5 satisfy the mean value theorem. It is within the interval of 2 and 8. So this number 5. Number c that satisfy the mean value theorem for the function x cubed over 3 interval 0 to 1. So this one. Interval at 1 0, 1 is 1. So somewhere along this curve, that one is c. So this one is a and b. This one your 0 is a, that one is b. So find or evaluate the functions at endpoints of f1. So f1 equals to 1/3. F sub 0 equals to 0. The derivative this one, f prime of c equals to 2c all over 3. So form an equation. So 2c all over 3 equals to 1/3 minus 0 all over 1 minus 0, or equals to 1/3. So 2c over 3 equals to 1/3. C equals to 1/2. So this means that c is in between of 0 to 1 or 1/2. So it satisfies the mean value theorem. So this one, x squared minus x plus 5. So find the value of c that satisfies. So that one is a there, this one is b, this one is c, and this one is your f of x. First step here is evaluate the function. So evaluate this one, 1 to 3. So f of 3 muna. So f of 3 equals to 3 squared minus 3 plus 5 equals to 11. So yung f of 1 equals to 1 square minus 1 plus 5 equals to 5. So find the derivative. So f prime of c equals to 2c minus 1. So form the equation. 2c minus 1 equals to 11 minus 5 all over 3 minus 1. Or this 1 equals to 6 all over 2 equals to 3. For 2c equals to 3 plus 1. Or c equals to 2. So this number c is in between of 1 and 3, the interval of the curve. Then it is in between 1 and 3 and satisfy the mean value theorem.